Hello again and welcome to another GCSE Computer Science Theory lesson. This video is going to be on Unit 1 and it's going to be covering the efficiency of algorithms plus pseudocode. Now I just want to talk to you what this video is going to cover. It's going to explain what pseudocode is and why you should be using it. I'm also going to go through the pseudocode for a linear search and for a bubble sort, plus how we can optimize the linear search and both the bubble sort. However, before continuing with this video series, it's important that you do understand some programming, otherwise you're going to get completely lost in these tutorials. So, moving on. Pause this video and just give yourself a moment to have a look at some of this code on the screen, and unpause when you're ready. Okay, so looking at this code, what strikes me instantly is that the pseudocode is by far the easiest to read out of these results. Even if we look at something like Visual Basic, even that one, as easy as Visual Basic is as a beginner's language, it is still more complex than pseudocode. And if we take a look at something like Java, I don't know why Java is so popular. That's absolutely horrendous code for a simple user input and an if statement. And C#, that's kind of like a happy medium between Java and Visual Basic.NET, to be honest with you. But I think most people would agree the pseudocode is by far the easiest to read. So that's one of the reasons why we use it. It is easy to read for non-programmers and programmers alike. Perhaps you're a Visual Basic programmer and you've never come across Java before. But it would be helpful if somebody gave you the pseudocode for that project before you started work on it to give you an idea of what's going on. Likewise, if you were a Java programmer and you weren't familiar with Visual Basic.NET, you could convert your code into pseudocode first and then manually port it over. So another advantage of pseudocode is that it is good for porting over to different languages. So you could take this pseudocode and you could convert it into any language you like. And I normally have a challenge with my students of give me any programming language that I've never done before, and I will do my best to port over some simple pseudocode. And I normally get some really disgusting languages out there, like Apple's implementation of Swift, which is just disgusting. Don't use it. At the end of this video, and you don't have to watch this, by the way, but right at the end of the video, I will attempt to try and convert this pseudocode here into a language called lolcode, which is a high-level language which is inspired by the language of meme cats on the internet. Okay, so moving on, I'm going to start coding a linear search for you into pseudocode. So first of all, I'm going to make a list. And because this is pseudocode, we don't have to worry about the syntax. And when I say list, what I actually mean is an array. So my list is just going to contain a bunch of numbers. There we go. So here is just a list of numbers, and how many things have we got on that list? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's add a 10th item in there, and there we go. And here is a very simple linear searching algorithm for you. We're going to make an iteration, so a loop that goes through every item in this list. So we're going to say for x is equal to 1 to 10. So we've got 10 items in our list. So this is going to be item number 1. This is going to be item number 10. And the reason why I'm doing this in pseudocode is because some students watching this video are going to be familiar with Visual Basic, some of you are going to be familiar with other languages, not to mention you are encouraged to use pseudocode wherever possible for the purposes of this AQA examination. So we're going through our list, 1 through to 10, and we're going to say if search term, so the thing that we're searching for. In fact, why don't we give the user an opportunity to type in their search term? So there we go. So this is where the user can type in their search term into a variable. So if the search term is equal to list x, so x is an index in this loop that's going to go through each item. So the first time we go through this loop, we're going to look at list number 1. The second time we go through this loop, we're going to look at list number 2, and so on. So if our search term is equal to the list, then we're going to output a message. Item found. And now I just want you to pause this video and point out why this is a stupid bit of code. What is wrong with this? Just pause this video and then pause when you're ready. Why is this stupid? Okay, the reason why this is rubbish is because let's say we're searching for the number 31 in our list. Okay, so we're going to say, is search term equal to 6? Nope. So we go around again. Is search term equal to 2? Nope. Let's move around. Is search term equal to 364? Sorry, 634. Nope, we go back around again until eventually we find what we're looking for and we just say item found. That's pointless though. I mean, can you find this for me? Yeah, sure, found it. Well, where is it then? Let's actually return to the user what they're looking for. And there we go. So whatever iteration we're at is going to be outputted to the screen. So if we were looking for, say, the number 2, well, we're going to find it on the second iteration. So that's going to be output to the screen. So 2 would be outputted to the screen if we were looking for number 2. If we were looking for number 34, then 1, 2, 3, 4, 5, 5 would be outputted to the screen. Now, there is a way we can make this more efficient. And when I say efficient, we're going to make the search time of this much quicker. But that is going to come at a sacrifice of some of the functionality. So in our previous video where we talked about linear searches, we said that even though, let's say we were looking for 31, once we find it, we're going to still carry on to the end. But what if there was a way to stop once we had found our item? Well, we could say something like exit once we found our search term. I mean, I know you can write whatever you like in pseudocode, but you have to write things within reason. So I've got a better way of ending this loop early once we found it. We can just say x is equal to 10. So there you have it. If we set x equal to 10, then this loop will end because this loop only goes to 10. And then that way, our search will terminate as soon as it finds an item, making it more effective. Just another tweak we can make to this algorithm to make it more manageable in terms of future programming. Rather than saying 1 to 10, we can say get the length of our list. And we'll replace this 10 here with the length of our list. And that way, if we were to add new items in, or minus items, that code is still going to work without making any changes by here. So next I'll talk you through the pseudocode for a bubble sorting algorithm, and just a quick reminder on how a bubble sorting algorithm works is that we take a look at 2 items at a time and then swap them if necessary, moving through the list like so, comparing 2 items, making our way through. So to do this, we'll start off with an iteration. And how many items do we have in our list? 1, 2, 3, 4, 5, 6, 7. So for x equals 1 to 7, and we're going to say if this item is bigger than this item, then we should swap them. And the code is going to look a little bit something like this. So if list x is greater than the item after it, so this is x plus 1. Okay. Once we've identified, so if this one is indeed bigger than this one, then we should swap them around. Alright then, so this is part of the code. There are a few problems. This only does one initial pass of the list. If you recall from the last video where I talked how the bubble sort actually works, you need to repeat this step for the length of the list. So we've got 7 items in the list. We need to repeat this 7 times. And to do that, we can just wrap another loop around it. There you go. There's still a few problems though with this code. One problem is that most languages don't have such a way of swapping items like this. It would normally take a few lines of code to get working. Another problem lies here with this code. Let's say we get to the 7th item in our list. We're going to say if list item number 7 is greater than list number 8, but there is no 8. This would cause the program to crash. So to fix this, we just change that 1 to 6, and then it's the problem solved. If we wanted to make this program more flexible, like we did with the linear search, we could just say length list. But for this one, we would need to say the length of the list minus 1. Now, if you're interested, and you're welcome to stop watching the video here, I'll talk you through how a swapping algorithm works. Now, most languages won't support this. I think Python does, but languages like Visual Basic and C#, there is no such function that will automatically swap items in a list. So I will talk you through at least one algorithm for it. So we could say so item 1 is going to be equal to item 2. And then the same thing in reverse. This is not going to work. This is going to break your code. The reason for this is, and I'll try and write it out up here. So let's look at this. Is 6 greater than 2? Yes, it is. So what we'll do is we will make x equal to x plus 1. And then we'll make x plus 1 equal to x. Do you see the problem? We've effectively just accidentally overwritten one of our variables, which is no good. So what we could do instead is make a temporary variable to store this in. So that would work if we could have some kind of temporary variable to store this inside. And I will code it. So we'll make a variable called temp. We will make it equal to the first item in our list to keep it safe. We'll then overwrite that first item in our list, and then we'll make the second item equal to what was in our temp. And there you have it, a fully working bubble sorting algorithm in pseudocode. And it's just up to you to port this over to something that Visual Basic can understand. In terms of optimizations, I'm going to show you some code that can optimize this and make it slightly faster. So if you recall from last lesson, as we keep on going through these iterations of our list, the largest number moves to the end, and therefore making it redundant to sort. So what we could do is make this iteration here shorter every time we go through this outer loop. So I'm going to make a separate variable called list length. And every time we finish going through the loop, so every time we finish the first one of those inner iterations, we're just going to decrement it. And there you have it, a considerably more optimized version of a bubble sort. Okay, one last thing, as I promised towards the start of this video, that I would convert this pseudocode into a language called lolcode for you, which I've done, and here it is. So if I type in something like 18, nothing happens. But if I type in 17, no car for you. Now I've got to be honest with you, this was more difficult than I thought it would be because of the way that lolcode handles less than or greater than statements in its language. Just to talk you through this code, this means declare a variable called user age. This means output user age to the screen. This means user age equals user input. And this just means if age is less than or equal to 17, and this means output no call for you to the screen, and this just means end if.